All right. Hey, excellent. The main speaker's here. So
The main speaker.
Ralph, do you want to have a quick intro first, and I will go?
yeah,
to
I'll introduce you. So Xing and I both worked together for many, many years at Alstom GE, where Xing was the director of our market systems R&D, as well as responsible for many of the major deployments. About 3 years ago, we split off. Xing went to Centrica, and I went to Amazon. But since then, we've continued the partnership. Amazon is kind of an infrastructure provider to an infrastructure provider. So all of the exciting stuff in this deck will come from Xing, and I will talk just a little bit about the core because most of what I need to talk about is fairly technical and not all that interesting. What Centrica has done is they've actually built a peer-to-peer energy network, and there's a lot of talking about this, and it's never clear whether we're on the front end of the hype cycle going to the peak or just coming off the peak and going down. But the reality is there's not a lot of actual working peer-to-peer systems with actual real customers. So this is one of the few in the world. I think it was an EU-funded project. It took about 3 years. We're coming to the end of the project right now. And so the key to getting through the hype cycle is to maximize the learnings from each deployment. And so Xing is going to take us through what happened, and some of it's the same as what's in the PowerPoints and the YouTube videos, and some of it will be a little bit more honest about what happened and what the next steps are. So over to you, Xing.
All right, I was on mute. Sorry. Thank you very much, Ralph. Thanks for the introduction. So let's go into the next slides. Yeah, and apologize, I don't have a nice background as Ralph has. I couldn't hide my massive background. So just a very quick introduction about Centrica. It probably is it's a new name for many of our colleagues on the Northwest, Pacific Northwest region. Centrica is actually a UK headquartered in UK. It's a leading international energy supply and solution providers. And in UK, our brand is British Gas. We're actually one of the largest natural gas and electricity supplier in UK. And in North America, our brand is Direct Energy. Probably many people have heard about that. And we also have a global brand, Centrica Business Solutions, which focus on the end-to-end distributed and clean energy solutions for commercial and industrial customers. Okay, so that's kind of the introduction. Go next slide, please. Yeah, just a quick word about Cornwall in UK. So this is a southwest peninsula of England. So the reason that we initiated this innovation project is because the recent years there are a lot of huge growth of solar and wind in that region, which actually lead to a very constrained network, and it's really a good opportunity to demonstrate, how DER could help address those network challenges and provide also values to our end users and consumers. Okay, next slide, please. Yeah, so we've talked about why we need a local energy market for distribution network or DNO or DSOs in Cornwall, using Cornwall as an example. But there's also needs from transmission operators to tap into the local flexibility or distributed flexibility, if you like, because I think, for example, in UK, the percentage of renewable energies in the grid is increasing every year rapidly, and those resources are intermittent, right? You do need flexibility to balance off the grid and keep the grid reliable, running reliably. And when both transmission and distribution require the local flexibility, then the question raised how the two needs can be coordinated, right, in terms of the network constraints and other boundary or operational constraints. The next slides, please. So in recent years, you can see that there's a real needs for local flexibility, and this is this slide provides some context for UK. So that needs really is growing, is becoming real, right? So how do we coordinate? So there are actually a number of companies are looking into the local energy market as well from different angles. Next, please. Yeah, so just to provide a very high-level overview of Cornwall LEM program. So this is a initially a 19 million pounds innovation program that partially funded by, actually largely funded by European Union and also partially funded by Centrica itself. So the main stakeholder, including Centrica, the transmission operator or the market operator in UK, which is National Grid, which you also refer to ESO, and also the local utility or the distribution. We also, I mean, the other key stakeholder, which is not showing here, is Ofgem, is the regulatory body. So because they're looking into the future DSO model for the UK market, and that is why they were kind of part of the program, and they're trying to also get the learning right for their policy development for the DSO model. There are also some of the universities participating in the program to trying to do some more research based on the work that we do. One work that, to summarize, is to really quantify the value of flexibility, local flexibility to renewable integration. In addition, that is obviously we get that from the ancillary services market revenue or customer. So there's for renewable integration for carbon reduction as well. So the key components of the programs. So there's certainly a LEM market platform. We also spend some budget on some of the business operations projects, including the installation, new installation of energy storage, wind and solar in that region, which result actually the true saving of the CO2 is about 9,000 ton CO2 saved per year by doing those projects. On the consumer side, we also installed sun batteries and PV panels for 100 home, and we aggregate those assets, home assets, through our virtual power plant platform, FlexPond, and offer those flexibility into the UK's wholesale market. So on the platform itself, so there's two phases. The first phase is really a very simple quote and tender. And then the second phase really is more sophisticated, but we're really focusing on the TND, transmission and distribution coordination. So what you're seeing here is a high-level architecture, which is actually the initial one. So you can see we actually included quite a bit scope in here. There's a short-term, mid-term, and long-term. We also included, like Ralph mentioned, the peer-to-peer transaction, through blockchain technology at the very beginning, because if you remember 4 years or 3 years before, 3 years ago, the blockchain is actually quite a hype. So we didn't want to miss the opportunity to test it out in this using this platform. But it's kind of an add-on stuff. I will mention that at the end through the lessons learned on what we see the blockchain as a technology for. And next slide, please. Yeah, so and this one is the actually the up-to-date software architecture. So apparently, everything is based in Amazon Cloud, AWS Cloud, and we heavily use microservices and a lot of state-of-art technologies, which will allow our development team to actually build this end-to-end platform in a very short time frame. Really, I think without the collaboration with from AWS, I think that is very difficult to do. Ralph, do you want to say just a few quick words about this?
Well, yeah, I mean, what Amazon provides, and AWS provides the core infrastructure for Amazon.com as well as Amazon Studios. And one of the big things to get innovation is to have a lot of experimentation. And the key to getting a lot of experimentation is to make sure you have an architecture that allows you to recover and not have to suffer from a lot of fallout from failed experiments. This is kind of a fundamental principle of how we got Amazon.com built. So what you see here is the adoption of a cloud infrastructure with a microservices architecture, in particular in this kind of a pilot operation, allowed a high level of experimentation with many partners. And this is applicable not only to pilots but to the real world, where as you've heard from all the speakers this week, things are changing pretty quickly. And so your core competitive advantage is going to be your ability to experiment and change, rather than some fixed asset or something that you have in place today. But yeah, I'm not going to get into the technical goobers underneath this thing. So
okay,
carry on.
Thanks, Raul. Yeah, thanks for the comments here. Let's move to the next slide. Yeah, so this is kind of going to deeper on the how LEM platform works. I don't want to spend a lot of time to talking details, but I think there's just at high level, there's months ahead. Long-term auction is really months ahead and a week ahead, and then there's a day ahead auctions and then intraday. So for the long-term auctions, really we're looking at capacity, right? And for the short-term or the real-time market or day-ahead market, we're really looking at the utilization of the flexibility, and we get bids from both the DSO and ESO at this for their requirements on flexibility, and then we get offers from our participants through actually virtual power plant aggregators onto the platform, and then we would run different auctions and publish the auction results, and also at the same time address the conflicts between the TSO needs and DSO needs. Okay, next slide, please. Yeah, so certainly we did about 50 plus auction runs, so we're still continue some of the auction runs with new assets coming on board. So yeah, it really those auctions test runs provides a lot of learnings for both. I mean, for all parties actually, really in this case. And if you search website, you probably can find some already published the report from WPD. I think the National Grid is writing their own report, and we will be publishing our own report very in coming months. So if you want to read more, just search Cornwall local energy market. You'll be able to find some of the research reports. Next slide, please. Yeah, so this is really the last slide, but I want to spend a couple of minutes on just going through some of the key lessons learned from this research program or innovation program. So first one is really that local flexibility has been viewed very critical for the decarbonization of the grid, right? And also to support, for example, the electrification of the heating, which is a big topic in UK, and also the transportation, right? So to reach the net zero targets in 2045, so those things will have to happen rather quickly, and that local flexibility is really important. So the LEM platform really demonstrates the feasibility of having both transmission operator and distribution operator to be able to procure concurrent flexibility service through a single spot market platform. And so there's definitely some complexity in how we run the auction, how the algorithm works, but this demonstration really proved that it can be done. And then apparently there's high interest from the end users, the consumers, to participate in LEM, but they don't want the flexibility. Really, that aggregators, I just want to emphasize, and you heard from the first presentation, that aggregator is really important to really bring the consumers or small customers into the markets without expose them to too much of the complexities of market knowledge or energy systems. So they want simple access. Also the LEM platform really, I think this is really from WPD's perspective and our perspective, really need to be integrated in some of these IT systems that implemented in the DNO today, for example, the distribution management system, the outage management system, because otherwise you would not be able to have the real-time network topology. And I think if you want to run power flow, you even need the real-time measurements, which so I think a lot or development need to be done to really support a fully functional local energy market. Yeah, so and also we mentioned the topology. I think we not just want the topology in real time, but also we want the kind of a scheduled outage in the future. So that really demonstrate the importance to also interface with the outage scheduler. One thing we mentioned already, that cloud-based technology, which actually really secure, pass all the penetration tests, that really enable our fast software development. If we do everything from scratch, we will not be able to really, in 1.5 years, develop such a sophisticated market platform, which is functional end to end. The last one I just mentioned, right? So people were passionate about blockchain a few years ago, and we decided let's test a few use cases leveraging this opportunity, and it's proven to be, I think, is a good technology. But I think the bottom line is so far we're struggling to find the real valuable use cases in the energy industry overall, and especially in the local energy market context. With that, I'll close my presentation and potentially maybe leave 2 minutes for any questions. And back to you.
Yes, thank you very much for that presentation. We do have about 3 or so minutes for questions. I'll lead with one. It's really a follow-on to the last point that you made. I'm connecting dots here as I'm listening to you, and something I think I've speculated about internally for a while is one of the challenges with the blockchain use cases tied to what you alluded to previously in your estimation, which is, hey, there's a big role for aggregators here in large part, I think, because you want to strip away the complexity and probably the interactivity requirements on customers, whereas blockchain would actually potentially foster that type of engagement. And is that one of the reasons that you're struggling to find good use cases, or are there other things that you've observed?
Yeah, so it's a good question. Thank you, Rich. And there's few reasons, right? One is certainly, if you really want to use blockchain to enable the transaction, you have to also work that into the current tariff, how do we do the billing and all the complexity, which is difficult to address, right? There's many other regulatory issues that you need to address. So that's one thing. And I think I'm not saying blockchain is not useful. It's actually quite useful to, for example, to track the renewable credit, green credit and things like that. But to use it, you have to. We ask ourselves, why do we have to use blockchain in this kind of experiment? Instead of other existing technology, mature technology, and the answer is not very clear. So that is why we decided to actually drop this scope during the I think the second year of the project and focus on the most valuable stuff.
Interesting. And just a final wrap-up question, as we really are pressing up against the top of the hour. Will your reports encapsulate any of your exploration specifically on this topic of blockchain, or not?
I can point to the different research report, because this blockchain was not the initial scope of the EU-funded program. It's really purely funded by Centrica, but I think we do have some relevant report that we can share.
Wonderful, thank you, and thank you to all of our panelists today for these 3 very compelling and interesting, Europe-based projects, as it turns out. I very much appreciate the time. Any questions, feel free to populate that chat box, everybody. We'll make sure we distribute those questions to the panelists. Thank you, everybody, for your time and engagement. We look forward to seeing you next time around in person. That concludes our presentation for today.
All right.
Thank you all.